Hello, welcome. Please comment down below if you're able to hear me so that you can continue. Hello, can you please comment below if you're able to hear me? I'm not even sure if the comment section is open. Okay. You'll just comment down below if there are any issues so that I'll be able to see your comments. You'll just comment it's not visible or there's any problem. Okay, we can start. Let us start with a prayer. Heavenly Father, we thank you for this day. We pray, Father God, that you may grant each and everyone understanding in the mighty name of Jesus Christ. We pray, amen. So we are gathered today to do Bsc N6, Building, Structural Construction, N6. So this is the question that I'll be doing, and this is called eccentrically loaded connections. This is called, okay, I can hear you, okay. Eccentrically loaded connections. So this is what we'll be doing today. And the question reads, the following figure shows a loaded bracket to support an eccentric load, 2 rows of black bolts. These are the bolts. These black things that you see here are the bolts. Okay, these black things that you see here are the bolts. And then it says 2 rows of black bolts are arranged to the spacing as shown. Use the following stress. We've been given the tensile stress, which is 5 MPa. We've also been given the shear stress, which is 100 MPa. So our question is, we need to calculate the diameter of the bolt. And then the second question is that we should calculate the actual stress induced in the bolt. Are we still okay? Are you able to hear me? Can we start? Please just comment down below then so that I know what's going on. Is the live paused or something? You can just copy down the question there and then draw this as quickly as you can so that we'll be able to start. It's okay, I can hear you, man. Okay. So this is the question. Let me just reread again. The following figure shows a loaded bracket to support an eccentric load. 2 rows of black bolts are arranged to the spacings as shown. Use the following stress values. We have been given the tensile stress, which is 145, and we've also been given the shear stress, which is 100 MPa. We need to calculate the diameter of the bolt and also calculate the actual stress induced in the bolt. Okay, so we can start now. Is it visible enough? The first thing that we're going to do when we answer this question is to determine the sum of LA squared. We need to determine the sum of LA squared. It's LEL squared. And then this is how we determine it. The formula is N into L plus L plus L plus L. So it's L1, L2, L3, L4. If you can check here, we have 4 bolts. We have 1, 2, 3, 4 bolts. So hence we have 4 L's. If you have 5 bolts, you'll write 5 L's there. So this is our question. I'll just read it for the last time. The following figure shows a loaded bracket to support an eccentric load. 2 rows of black bolts are arranged to the spacing as shown. Use the following stress values. Tensile stress is 145, and then the shear stress is 100 MPa. We need to calculate the diameter of the bolts and also the actual stress induced in the bolts. This is the eccentrical load that we'll be doing. We are given 100 kilonewton. This is the force. This 100 kilonewton is the force. And then we have 250, which is E. This is represented by E. And then we have this numbers there. How many bolts do we have? 1, 2, 3, 4. You count this black things, you have 4 bolts now. However, they said you have 2 rows, so when you need to substitute the number of bolts, you need to substitute 8 instead of 4. Why are we substituting 8? We have 4 bolts that we are able to see. However, in the question they told us that it is 2 rows, so it's 4 multiplied by 2. It is the number of bolts multiplied by the 2 rows. So the total bolts are actually 8 and not 4. We are able to see 4. However, check the statement. They told us that it is 2 rows. They told us that it is 2 rows, so it is 4 multiplied by 2. Okay, so now we can start. The first thing that you are going to do is to determine the EL, the sum of LA squared. So here it is. This is the formula that we'll be using. The sum of LA is equal to N into L1, L2, L3, L4. It is not always L1 to L4. It depends on the number of bolts that you have. So currently we are seeing 4 bolts. This is our bolts, 1, 2, 3, 4. Hence the L's are only 4. If you have 5 bolts, you'll write L1 until L5. So on the N, this N is not for the number of bolts. The N that is there is not the number of bolts. Just give me a moment. Okay, this N is not for the number of bolts. This N represents the number of rows. The number of rows. The 2 is for the number of rows. So they told us that we have 2 rows there. They said we have 2 rows. Hence here on the N we're going to substitute 2. So it's 2 into LA, L1. The first L is this 45. You're going to substitute this 45 that you're given. It is the first number. So the L1 is 45. 45. L2, your L2 is not going to be 80. When you're doing this type of eccentrical load and you want to substitute an L2, what you're going to do is you take the bottom one, which is 45, the one that you used at first, and then you add 80. So let me calculate 45 plus 80. I'm getting 125. So 125 is my L2. 125 is my L2, 125. So, okay, this is how you do it. For L1, you choose the first one, which is 45. Then for L2, you take the bottom one and then plus the second one. So it's 45 plus 80, which is 125. So our L2 is going to be 125. And then for L3, you're going to start at the bottom. You add 3 times. 45 plus 80. This is the 45 that I'm adding, plus this 80, and then plus the third 80. Again, it's L3. So you add 3 numbers plus 80. What are we getting? We're getting 205. So 205 is our L3. L3 is equal to 205. And then for the last L, remember I said you check the number of bolts that you have. If you have 4 bolts, you will have 4 L's. If you have 5 bolts, you will have 5 L's. So this is the last L because we have 4 number of bolts. So how are we going to do the last L? It's going to be 45, this 45 plus 80, the second 80 plus 80, the third 80 plus 80. Wait, how many 80s do we have? Yeah, 3. So what do we have there? We have 285. So it means our L4 is 285. Let me just repeat that again. Let us restart. We have an eccentrically loaded connection that we are doing here. They gave us the tensile stress, which is 145. They gave us a shear stress, which is 100. They said that we have 2 rows. These are 2 rows. They mentioned it here. We have 2 rows on this eccentrically loaded beam. So how many bolts do we have? We have 4 bolts. However, we're going to multiply the number of bolts by the rows. How do you identify the bolts? This black things that you see here, these black things, these are bolts. So here we have 4 bolts. But all in all, how many bolts does this eccentrically loaded connection have? It's 8. How do we get the 8? It is 4. We multiply by the 2. Okay, so the first thing that you do when you answer this question, it is to determine the sum of LA squared. Determine the sum of LA. So this is the formula. Sum of LA is equal to N. This N is not for the number of rows. It is not for the number of bolts, it is for the number of rows. So how many rows do we have? They said we have 2 rows, hence I substituted 2 there. It is not the formula. Maybe someone can say, oh, it is always 2. It is not always 2. It depends on how many number of rows do you have. How many number of rows are you given? This one, they said it's 2 rows, hence I substituted 2. So this 2 is not a formula. It depends on what number of rows you are given. And then L1, L2, L3, L4. It depends on how many bolts do you have. I have 4 bolts, which is 1, 2, 3, 4. 4 number of bolts. Hence here I wrote 4 L's. If I had 5 bolts, if I had 5 of these black things, I would have written 5 L's. So it's 4 now because I have 4 number of bolts. So this is 1, 2, 3, 4. How many bolts do you have? 1, 2, 3, 4. So it's 4 L's, which is equal to 4 bolts. So this first L, we are going to use the first bottom number, which is 45. This is our 45. The second L, you are going to say, the second L is not 80. The second L will be 45. You take 45, you take the bottom one, plus 80. What do we have? We have 125. So that means our L2 is 125. And then for L3, you're going to say 45 plus 80 plus 80. If it's 1L, you take 1 number. L2, you take 2 numbers. L3, you add 3 numbers. Hence, on L3, we said it's 45 plus 80 plus 80. So 45 plus 80 plus 80, it gives us 205. Hence, our L3, we've written down 205. And then for L4, remember, if it's 4, you add 4 numbers. So it's going to be this 45 plus 80 plus 80 plus 80. You add 4 numbers because it's L4, right? So there you have it, it's 285. So hence here I've written down 285. Let me know in the comment section if I can continue, if you've understood this part. This is 2, okay, plus 205 plus 285. So each and every number, we are going to square it. Remember here I said we determine ELA squared. So each and every number you need to square it. 45 you square it, 125 you square it, 205 you square it, 285 you square it. So on the formula you can say it's 1.2, it's 2.1, meaning that it's L squared, but it's the first bolt. L squared, but it's the second bolt. Again, you would have said maybe 2.2 and then 2.3, 2.4, like that. So is 2. This N is the number of rows. They gave us 2 number of rows. We have 4 L's because we have 4 bolts. So the first L, you take the first number, which is 45, the bottom one. You start at the bottom. And then L2, it's two numbers, which is 45 plus 80. L3, it's 45 plus 80 plus 80. And then L4, you take four numbers, 45 plus 80 plus 80 plus 80. And there we have it. Remember to square, because you are looking for the sum of LA squared. You need to square. So let me check what I get to into 45 squared plus 125 squared plus 205 squared plus 285 squared. I'm getting 281,800. Let me know in the comment section if you're getting the same answer, because this answer that we found here, we'll be using it for so many things. So if we got it wrong right now, our things will be wrong. So just comment down below, I got the same answer. If you got the same answer, I'm getting 281,800. No, 281, yeah. I'm getting this, 281,800. Then this is in millimeters squared. I got 281,800. I got the same answer. Okay, noted. Okay, before we can continue, let me just go back. Okay, forgive me for always going back. I just need everyone to understand it is useless for us to do this whole question, but you missed the first step. So it's important for you to understand each and every step. Okay, so we have a question there. What we're doing today is called eccentrically loaded beam. So we have a question there which says, the following figure shows a loaded bracket to support an eccentric load. Two rows of black bolts are arranged to the spacing as shown. Use the following stress values: tensile stress, which is 145 MPa, shear stress, which is 100 MPa. The question is, we have to calculate the diameter of the bolt and also to calculate the actual stress induced in the bolt. So this is the eccentrical load that we have. They've given us E. E is this 250. It is from the center of the bolt until the position of the load. Each and every time when you are dealing with eccentrically load, note that E is equal to the number that starts in the middle of the column till the position of the load. A load is a force. So as you can see there, the E starts in the of the column. This is the middle of the column until the position of the load. This is the position of the load. The load is the force. So that is our E. It is 250. This is the eccentrical load that we are given. We are also given 100 kilonewton, which is the force. So now let us answer. The first step that you're going to do, it is to determine the sum of LA squared. We determine the sum of LA squared. So the formula is this one. Sum of LA is equal to N. This N is for number of rows. Why did I write 2 here? They said we have 2 rows. Hence, I've written down 2. N is for the number of rows. And then you open your bracket, you write 4Ls. Why are we writing 4Ls? It is because we have 4 number of bolts. 1, 2, 3, 4. You have 4 number of bolts. If you have 5 number of bolts, you will write 5Ls. So right now we have 4 bolts. 1, 2, 3, 4. So if you have 4 bolts, you're going to get the sum of 4 bolts, which means it's 4Ls. So this is L1, L2, L3, L4. Someone else can say, or maybe your textbook can say L2.1 plus L2.2 plus L2.3 plus L2.4. This is L1, L2, L3, L4. So this squared, it is because we are looking for the sum of LA squared. If you can notice here, I've squared each and every L that we got. Each and every L that I substituted here, I've squared it. So someone else can use this formula. This formula and that formula, they are the same thing. This one simply means it is L squared. My L, I'm going to square it. And then what does this one stand for? It is 1 bolt. It is the first bolt, the second bolt, the third bolt, the fourth bolt. Okay, so the first thing that you do here is to determine the sum of LA squared. So sum of LA squared is equal to n, which is number of rows, and then you write your 4Ls. Why is it 4Ls? It is not always 4Ls. Do not cram that it is 4Ls. It is only 4Ls here. We're only adding 4Ls because we have four number of bolts. If you have more, then that means you will have more Ls here. Okay, so remember to square all your Ls. So 45, the first L, this is the 45 that we are using. You start at the bottom, not at the top. It's not this 45 at the top. It is this 45 at the bottom. You start here going upwards. So L1 is 45. This is the first bolt. And then L2, you say 45 plus 80. L2, you say 45 plus 80, and then we got 125. L3, you say 45 plus 80 plus 8. If it's L2, you add 2 numbers. L3, you add 3 numbers. L4, you add 4 numbers. What grade? This is Bsc N6 for civil engineering, building structural and construction, whatever it is. Yeah, Bsc. Building structural construction, something like that. It's N6. Okay, let's continue. So as I was saying, L1, remember to start at the bottom. L1 is 45. This is the 45. L2, it's 45 plus 80. L3 is 45 plus 80 plus 80. For L3, you add 3 numbers. L4, 4 numbers. L5, 5 numbers, like that. Then remember to square that. We got 281, 800. The SI unit is millimeter squared. Can I continue? Are you okay? Are you fine? Did you understand the first step? Just comment yes, no. Can you repeat so that I can continue? Okay, so after calculating, the first thing you calculated LA squared. So now let me say it's A, then because the questions are 1, 2. The second thing that we're going to calculate, we are going to determine the tensile load. Determine the tensile load. Determine the tensile load. That's the second thing. The first thing that we did was to get sum of LA squared. So now the second thing is for us to determine the tensile load. How do we determine the tensile load? The formula is Ft moment. The formula is Ft moment is equal to P multiplied by E multiplied by LA divided by sum of LA. We are determining the tensile load. The formula is Ft moment is equal to P. On this P, you're going to substitute the force. On the P, you're going to substitute the force. Remember, we're given a force of 100 kilonewton. That one here, kilonewton, it's 100 kilonewton. That is our force. So P represents force. You're going to substitute the force that you have. And then E, I said E is the number that's in the middle of the column till the position of the load. There is our E. It's 250, okay? And then our LA, on this LA, you substitute the last LA. You substitute the last LA. Which one is the last LA? We calculated sum of LAs here, right? So the last LA is 285. So it means we're going to substitute 285 on that formula. So right now we are determining the tensile load. The formula is Ft moment is equal to P, and I said on this P you substitute the force. If it's given in kilonewton, you need to multiply by 10 to the power of 3. So since our force is 100 kilonewtons, it means we're definitely going to multiply by 10 to the power of 3. And then E, it is this 250. E, it is this 250. And then LA, we substitute the last one. Substitute the last LA. You divide everything by the sum of LA. So P, it is 100. As I said, P is the force. There is our 100 there, 100 kilonewtons. And I said if it's in kilonewtons, you multiply by 10 to the power of 3. So P is 100 multiplied by 10 to the power of 3 multiplied by E. Which one is E? Our E is 250. It's the one that starts in the middle of the column. This is the, as you can see, it starts here. This is the middle. This is the middle. It starts in the middle of the column till the position of the load. So there is our E. It is 250. Substitute 250 multiplied by LA. Here on LA, I said we substitute the last LA. Which one is the last LA? We calculated sum of LA there, and the last one was 285. So that is what I meant by the last LA. So we multiply there by 285. And then you divide by the sum of LA. We got the sum of LA. It is what we were calculating on the first step. We got 281,800. We got 281,800. So the first thing that we did, we calculated the sum of LA squared. Now we are determining the tensile load. And for the tensile load, the formula is Ft moment is equal to P. This P is force. This P represents the force. And then multiplied by the E. This is our E. The 250 is our E. It is the number that starts in the middle of the column till the position of the load. And then multiplied by the LA. You don't just substitute any LA. This LA is the last one. So it is 285 divided by sum of LA. Which one is the sum of LA? It is the one we got in the first step, 281,800. 281,800. So there we have it. And I'm getting 25,3 kilonewton. Just comment down. Just comment down below if you got the same answer. Because if we get this answer wrong, our entire thing is wrong. It'll be wrong. So let's just calculate again. 100 times 10 to the power of 3 times 250 times 285 divided. Okay. Are you all getting the same answer? You are probably getting 25,283,88928. Divide that by 1,000. Divide that by 1,000. You will get 25,283, which is 25,3. This is what I'm getting. This bigger number that you get, it is in Newton, so divide that by 1,000. You'll get 25,3. Are you all getting the same answer? I got 25,3 kilonewtons. Okay, after you've gotten your 25,3 kilonewton, inside your brackets, you should write that this is resultant force. It is the resultant tensile force. You add tensile there, resultant tensile force, which is represented by P. This is P. Resultant tensile force, which is P. Okay, now let us move. We are now going to calculate the FS load. We are now going to calculate, we determine load FS. We determine load FS due to direct shear, Remember, we're given two stresses, the tensile and also the shear. Hence, we're determining each and everything double for the tensile and also for the shear. So determine load Fs due to direct shear. The formula is force direct. Force direct is equal to the force divided by the number of bolts. Force direct is equal to force divided by number of bolts. What is our force? Remember, our force is 100 kilonewtons. The formula is F direct is equal to the force. So our force is 100. It is 100 kilonewtons. And then we need to divide by the number of bolts. What is our number of bolts? Remember, I said the bolts are these black things, 1, 2, 3, 4. However, you're not going to substitute 4 there because they said you have 2 rows. You have 2 rows. So if you have 2 rows, this means you're going to say 4 multiplied by 2. What is 4 multiplied by 2? It's 8. So on this formula, we are calculating the force direct. You're going to say force divided by the number of bolts. So force is 100 kilonewton. They gave it to us. The number of bolts, we see 4 there. It's 1, 2, 3, 4. However, they said it's 2 rows. So you take that number of bolts that you're seeing there and you multiply by 2. So what do we get? We get 8. So what is 100 divided by 8? 100 divided by 8. I'm getting 12,5. I'm getting 12,5, and this is in kilonewtons. Just let me know if you're getting the same answer, 12,5 kilonewtons. And then in brackets, you'll write that this is the resultant shear. This is the resultant shear load, which is represented by Q. For the tensile, we said it is the resultant tensile load, which is represented by P. So Q is for the shear. P is for the tensile, and then Q is for the shear one. Are you getting the same answer as I got, 12,5? Just comment down below. P is the tensile, Q is the shear. There is our Q, it's 12,5. And then now let us move. Okay, so the first thing we calculate was the sum of LA squared. Then the second thing that we calculated was the tensile load. Then the third thing was the shear load. It was the shear load. And then for the LA squared, which formula do we use? Sum of LA is equal to N into L1 plus L2 plus L3 plus L4. We are ending up at 4 because we have 4 number of bolts. We have 4 number of bolts in a row. Hence, the L's ended at 4. So if you have 5 number of bolts, you would end at L5. So the first thing we calculated was the sum of LA. This is the formula that we used. N, which is for the number of rows. So on the number of rows, you will substitute the number of rows that they gave you. So here they gave us 2, and we substituted 2. And then L1, L2, L3, L4. Or I said you can use this formula, N into L 2.1. This 2.1 means your L, you're going to square it, but this is for the bolt number 1, and then plus L 2.2, you're going to square this L, but it's for bolt number 2. It's L 2.3, you're going to square this L, but it's for L3, and then L 2.4, you're going to square this L, but it's for bolt number 4. N is for the number of rows, and then L. Let me just go back a little to where we started. this is where it all began. Our n, we said, is the number of rows. Where do we get the number of rows? It is this 2. They said we have 2 rows there, so we substituted the 2. And then L1, we got 45. Where are we getting this 45? We said we start at the bottom. It's this 45, not this 45 at the top. It is this 45. And then for L2, you're going to say 45 plus 8. If it's L2, it means it's a bolt number 2, so you add 2 bolts. L3, you add 3 numbers, so it's 40. For L3, it's 45 plus 80 plus 80. Remember to start at the bottom. Each and everything of yours, your L's, you start at the bottom. L4 is going to be 45 plus 80 plus 80 plus 80, and this is what we got. L1 is 45, L2 is 125. Why are we getting this 125? We said it is 45 plus 80, and then L3, we got 205. Where are we getting this 205? We said it is 45 plus 80 plus 80 plus 80. And then for L4, we got 285. We said 45 plus 80 plus 80 plus 80. So the reason why I'm not adding this 45 is because we have 4 L's. It's 4 number of bolts. And I said if it's 4 bolts, you add 4 numbers. So this is where it ends. 1, 2, 3, 4. Okay? So there we have it. Our first step, we got 281 800 millimeters squared. Then the second thing is for you to calculate the tensile load. So there is the formula for the tensile load. It is Ft moment is equal to P multiplied by E multiplied by LA. The P is for the force. You substitute the force that you are given. We were given a force of 100. And then our E, it is the 250. Where are we getting the E? It is the number that starts at the center of the column till the position of the load. So it's 250. That is what we substituted. And then LA, this LA, it is the last LA. Which one is the last LA? It is L4. Where is our L4? There we have it. It's 285. Hence, I substituted 285 there. Then we divide everything by the sum of LA, which is 281800. And you got 25.3 kilonewton. The number that you'll get will be this one. It will be a huge number divided by 1,000 so that you'll be able to get your number in kilonewtons. So first step is the sum of LA. Second step, Ft moment, which is the tensile load. Then the third step, it is the load for the shear, which is force direct. It is equal to the force. Our force is 100 kilonewton divided by number of bolts. I said on the number of bolts, you don't substitute the 4 that you see. Here our bolts, we have 4 number of bolts, 1, 2, 3, 4. However, when you substitute on that formula, you substitute 8. Where are you getting the 8? It is 1, 2, 3, 4 multiplied by 2 rows. This 4 that you are seeing, it's only for 1 row. So you need to get the total number of bolts for the whole eccentric load. Hence, on the number of bolts, I substituted 8, and then we got 12.5. So yeah, number 1A, it is the sum of LA squared. B, the tensile. Remember to write in brackets that this is P. Just like this one, you're going to write resultant tensile load P. And then C, it was for the shear load. The shear load, which is represented by Q, we got 12.5. Then now let's move. Let us continue. So the fourth thing, we're going to be calculating the equivalent tensile load. Equivalent tensile load. So for the equivalent tensile load, the formula is PE is equal to half into P plus the square root of P squared plus 4Q squared. We are calculating the equivalent tensile load. The formula is PE, which is equal to half into P plus P squared plus 4Q squared. So that is the formula for equivalent tensile load. And then this is going to be half. What are we going to be substituting on our P? On the second step, when we were calculating the tensile load, I said in brackets you should write that this was the resultant tensile force, which is P. So this P, we got 25.3. It is the P that we are going to substitute right now. It is the P that we're going to be substituting right here, which is 25, It's 25, I think it's 25,3. Yes, 25,3. The P is 25,3. You can make an error there to show that this P is for the tensile load that you calculated, 25,3, and then plus the square root. P again, the same P, 25,3, you square it, and then plus 4. What is our Q? Our Q is the shear one. We just calculated it in step 3. We got 12,5. Then we square it. Let me check what we get. You can also calculate there and comment down below if you're getting the same answer. It is half multiplied by 25,3 plus the square root of 25,3 squared plus 4 times 12,5 squared. What are you all getting? Just give me a moment to calculate. I'm calculating half into 25,3 plus square root of 25,3, I square it, plus 4 times 25,3 squared again. I'm getting 40,94. Please confirm if you're getting the same answer or I made a mistake on my calculator. Half 25,3 plus 25,3 squared. Are you getting the same answer as I'm getting? This is what I'm getting. Are you getting the same answers? 30,43. I'm sure I made a mistake somewhere. Okay, let me recalculate. Half into 25,3 plus the square root of 25,3 squared plus 4 times. Yeah, all good. 30,43. It's in kilonewtons. Are we all getting 30,43 half? Okay. D, and then now for E we're going to get the equivalent shear load. We're now going to get equivalent shear load. Shear load will be QE. Tensile is PE, shear is QE. So it's QE is equal to half the square root of PE plus 4Q squared. That is the formula. You can write it down there. That is the formula, half square root of PE plus 4QE. Okay, so this is half and then into square root. What is our PE? No, this is P squared, sorry. What is our P squared? The P, this is the P that we substituted here, 25,3, the tensile one. The one we got in letter B. P is 25,3. Then we square it plus 4. What is our Q? It is the shear one. We got this in letter C, which was 12,5. So what are we getting? This is half square root of 25,3 squared because it's P squared, and then plus 4Q squared. Q, you substitute 12,5. What are you getting now? Half the square root of 25,3 squared plus 4 times 12,5 squared. I'm getting 17,78. Are you getting the same answer? 17,78 kilonewtons. I'm getting 17,78. This is what I got. Okay, yes, same. All right. 17,78 noted. Okay, let's just go back a bit just for a second. This is the question we are doing, right? So in this question, the most important thing is that they said it is 2 rows there, and then, okay, I'm rereading this again. The following figure shows a loaded bracket to support an eccentric load. Two rows of black balls. These are the black balls. These black things that you see here are the black balls. They are arranged to the spacing as shown. Use the following stress values. We've been given the tensile, which is 145, and also the shear stress, which is 100 MPa. This is the eccentric load. We have 250, which is E. I said this 250 is E. And then 100 kilonewton, this is the force. They can sometimes say load. So load and force is the same thing. And then the first step that we're going to do, it is to calculate the sum of LA. So the formula is N into, you can say L 2.1 plus L 2.2 plus L 2.3 plus L 2.4. So why are we ending up on 4? It's because we have 4 bolts. If you had 5 bolts, you will do L1 until L5. 6 bolts, L1 until L6. Hope you understand that. It is not always up to 4. Here it is. We ended up at 4 because it was 4 bolts. So this N is for the number of rows. They told us that we have 2 rows. And then L1, how do you get the L1? You start at the bottom, it's this 45, the first number. And then L2, you're going to say 45 plus 80. L3, 45 plus 80 plus 80. L4, 45 plus 80 plus 80 plus 80. For L4, you need to add 4 numbers. For L3, 3 numbers. For L2, 2 numbers. For L1, 1 number. Okay, and then square each and every L that you got. We got 281,800 millimeters squared. So that's the first step. And then we go to the second step. The second step is to calculate or to determine the tensile load. So how do we determine the tensile load? The formula is Ft moment. Ft moment is equal to P. This P is for the force. This P is for the force, which is multiplied by E. The E is this 250 that you see here. This is E. So P, you're going to substitute 100, and then E, you're going to substitute 250. Okay? And then I said, if you are given the force in kilonewtons, you need to multiply it by 10 to the power of 3 when you substitute it in this formula. So as you have seen there, our 100 is in kilonewton. Hence, we multiplied there by 10 to the power of 3. It is not always multiplied by 10 to the power of 3. Right now, it's because it was in kilonewtons, okay? And then our E is 250. The LA that you substitute here is the last LA, meaning this is L4. In this case, the last LA, which is L4, it is 285. Okay, then we divide by sum of LA. Where is the sum of LA? Is the one that we were calculating there on the first step. Okay, so first step, we calculated sum of LA. There you have it. Second step, you determine the tensile load using this formula. Remember to write this at the bottom. This is a resultant tensile force, which is represented by the letter P. It is represented by the letter P. So each and everywhere where you're going to see P from this step onwards, you're going to substitute the answer that you got here, this 25,3. Okay. Then the third thing, we're going to determine the load Fs. This is the load due to direct shear. So it's force direct, which is equal to force. What is our force? 100 kilonewton. What is our number of bolts? I substituted 8 there, but where are we seeing the 8? Because there's no 8 here. The only number of bolts that we're able to see is 4. It is 1, 2, 3, 4. So where is the 8 coming from? It is 2. It's 2 rows. You take your number of bolts, which is 4, you multiply with the number of rows. That is why here we wrote 8. Okay, let me just say it is 4 multiplied by 2, so that you'll be able to remember. We multiplied by the number of rows. It is 4 bolts multiplied by the number of rows, and then you get 8. It's 12,5. Remember to write this so that you don't forget what to substitute in the coming formulas. Resultant shear load, this is Q, okay? P is tensile, Q is the shear. So the first step is sum of LA squared. Second step is the tensile, which is represented by P. Shear, which is represented divided by Q. Then now we go to the fourth step. The fourth step is to get the equivalent tensile load. Equivalent tensile load. So the equivalent tensile load, this is the formula. PE is equal to half into P plus the square root of P squared. What are we going to substitute on this P? Remember, this P is for the tensile. Okay, this P is for the tensile. The number we got on tensile, letter B, on step 2, it is what we are going to substitute here. So P, we got 25,3. Still the same P, 25,3. You square it. The Q is for the shear. The shear load, we calculated it in step 3. This is the shear load, is 12,5. And then we got 30,43. Now we need to calculate the equivalent shear load. So for the equivalent shear load, it is QE, which is equal to half. You open a square root, P squared plus 4Q squared. Half square root P squared plus 4Q squared. And then P, you substitute for the tensile. This P, it is the tensile one. It is the tensile load. The P is the tensile load. And then Q, it is the shear load. So you substitute, we are getting 17,78. Hope you all got the same answer, 17,78. Okay, so now we move. Now we are moving. We are going to calculate the combined. We're going to calculate the combined tensile stress. The combined tensile stress. And I don't think this question is there in any of the question papers. If it's there, maybe it might be just one or a few. So you might be the first to write this one. Sorry. Okay, so now we're calculating the combined tensile stress. So the formula is PT, which is equal to PE divided by the area. That is the formula. PT is equal to PE divided by the area. So what is our PE? Remember, we just calculated PE there, the equivalent tensile load. So let's just say PE is equivalent tensile load. So PE, that is what we are going to substitute. The number we got there on step D, which is 30,43. We got 30,43. And then it is in kilonewton. We need to multiply by 10 to the power of 3. And then we divide by our area. Where are we getting this area? The area, okay, sorry. Let me just write another formula. I'm going to write this formula, and then you write that PT is equal to the area, which is equal to PE divided by the PT. So area is equal to our PE, which is 30,43. Do not forget to multiply by 10 to the power of 3 if you are given in kilonewton. And then our PT, it is the stress that you are given, the tensile stress. PT, it is the tensile stress. PT, this is the stress. They gave us 145. Why are we using a 145 for tensile? It's because we're calculating the combined tensile stress. When we calculate the combined shear stress, we're going to use the stress for the shear. Hope you get that. So PE, it is what we calculated in step D, 30,43. It was in kilonewton, so you need to multiply by 10 to the power of 3. And then PT is the stress, which is 145. So what are we getting? Let's all calculate and comment our answer. 30,43 times 10 to the power of 3 divided by 145. I'm getting 209,86. This is the answer I'm getting. What are you getting? 209,86 is what I got. Let's just confirm. I got 209,86. Are you getting the same answer? Okay, this was step E, step A, B, C, D, E, F. This is step F. And then step G. This is the last step before we can answer our question. So step G is to calculate the combined the combined shear stress. Combined shear stress. So for the combined shear stress, the formula is Fs, which is equal to QE. QE divided by the area. And then area, I'm still behind. Please do it again. Okay. Which one, F or I go back to D? Do I start here at F? This is F. Do I start here at F? Let me just go back to F. For sure you're here. You're behind here. Okay. Okay, F. So on F, we're calculating the combined tensile stress. So when we calculate the combined tensile stress, the formula is PT, which is equal to PE. This PE stands for equivalent tensile load. And remember, we calculated PE in step D. This is our PE. PE, which you got to be 30,43. So that is the PE that we're going to substitute that answer. It was 30,43. And since it is in kilonewton, you need to multiply by 10 to the power of 3 when you substitute. That is why we substituted there. So the formula is PT is equal to PE divided by the area. And then you come here, you say PT is equal to area. PT is equal to area, and then area, which is equal to PE divided by PT. So the formula is practically area, which is equal to PE divided by PT. So what is our PE? The one we calculated in step D, which is the equivalent tensile load. We got 30,43. It is in kilonewtons, so we need to multiply by 10 to the power of 3. And then we divide by PT. PT is the stress. Remember, we are calculating combined tensile stress. So we need to use the stress that they gave us, the tensile one. They gave us 145. So this is where the 145 is coming from, this one that I substituted there. And we got 209,86. It's in millimeters squared. Okay, and then we go to G. G, we calculate the combined shear stress. Combined shear stress, the formula is Fs, which is equal to QE divided by the area. Fs is which is equal to QE divided by the area, and then area, which is equal to QE divided by Fs. So now we substitute. What is our QE? We got the answer in E, 17,78. We got 17,78. Remember, it's in kilonewtons. So what do? We multiply by 10 to the power of 3. And then we divide by our Fs. Our Fs is the shear stress. Where is it? They gave us, divide there by 100. You use the shear stress that you are given. So I'm getting 17,78 times 10 to the power of 3 divided by 100. I'm getting 177,8. I'm not sure what you guys are getting. 177,8. Remember, it's area, so it's millimeters squared. Are you getting the same answer as I'm getting? 177,8. This is the answer I got. 177,8. Just confirm in the comment section if you got the same answer. Okay, so let us just write down our steps. Okay, we are doing an eccentrically loaded connection. We are doing an eccentrically loaded connection, and then the first thing that you do, the question said they wanted us to calculate the diameter and the actual stress. So the first step was for us to get the sum of LA. So for us to get the sum of LA squared, we use the formula that says LA is equal to N into L 2.1 plus L 2 plus L 2.3 plus L 2.4. And I said it is 4 L's because you have 4 bolts. If you have 5 bolts, it means it will be 5 L's because you have 4 bolts. And then we go to B. B, we calculate FT moment. FT moment, this is the tensile load. Tensile load. The formula is FT moment is equal to P multiplied by E multiplied by LA divided by sum of LA. And then on sum of LA, you're going to substitute this one that you got. As you can see, step A, the formula says sum of LA. So it means here on sum of LA, you're going to substitute what? The one you got on step A. And then P, I said it is the force. And then remember to multiply by 10 to the power of 3 because it is in kilonewtons. And then E is that number at the top. Let me just show you again. E, this is E. The 250 is our E. Okay. And then LA, you substitute the last one. You substitute the last LA. And in this case, this is L 2.4. Okay. And then C, we calculate the load due to shear. Load due to shear, which is force direct. Force direct. The formula is force divided by the number of bolts. And then on the number of bolts, you don't substitute what you see. You do not substitute what you see. Again, what you see is the 4 bolts. You don't substitute that. You do not substitute what you see. You substitute the number of bolts that you see multiplied by the number of rows. So this formula F direct, we said the force is 100 and the number of bolts, we said it's 8, although we don't see 8. It's because you substitute the number of bolts, which is 4, multiplied by the number of rows. So it gave us 8. And then D, we calculate PE. D, we calculate PE. What is PE? It is the equivalent tensile load. Then what is the formula? PE is equal to half P plus the square root of P squared plus 4Q squared. Then E, we calculate QE. What is QE? It is the equivalent shear load. And then the formula for QE is half the square root of P squared plus 4Q squared. So that's it. And then we go to F. F is this one that we're calculating just now. It is the combined tensile stress. And the formula is area, which is equal to PE divided by PT. PE, it is the one that you calculated here on step E, the equivalent tensile load. This is step E, which is the equivalent tensile. And then PT, it is the stress given, the stress that you are given. Then we go to G. G, we calculate the combined shear stress. So for combined shear stress, the formula is area is equal to QE divided by FS. On FS, you substitute the stress given. Which stress? The shear one. Again, we are calculating the combined shear stress. Then this is it. We are done. Now, We need to calculate. We need to answer the question. Did you understand all this from step A to step F before we continue till step G? Step 1 is sum of LA squared. That's the formula. Step B, the tensile load. Step C, the load due to shear. D, it is PE. E, it is QE. And then F, the combined tensile. G, the combined shear. That's all. Now we need to answer the question. What did the question say? The question said they want us to determine the diameter of the bolts, okay? So for us to determine the diameter of the bolts, now we are answering. Now you can say this is number 1. We are answering number 1 right now. When we answer number 1, you are going to say use tensile stress. Use tensile stress to find a suitable bolt. Remember, we're looking for a diameter of suitable bolt. There's the diameter of a bolt. So since they gave us a tensile stress and also a shear stress, it means we need to get D. We calculate D 2 times. We calculate D for tensile. We also calculate D for the shear. So the formula is area is equal to pi D squared over 4. We are answering the question now. They said they want a diameter. So we use tensile stress to find a suitable bolt. Area is equal to pi D squared over 4. What is the area that we got for the combined tensile stress? Again, this statement says we use the tensile stress. We calculated the tensile stress. Where is it? The combined tensile. I can't find it. I don't know where I've written it down. Just type it down for me. I can't find it. We calculated it. I'm not finding it. What was the combined tensile? What was the combined tensile? On step F, I want the answer for step F. Answer for step F, what was it? Oh, got it, 209,86. We had gotten 209,86. So that is what we are going to substitute here on area, 209,86. Then this is equal to pi D squared over 4. Okay, so since we want D, we're going to cross multiply, and then it'll be 209,86 multiplied by 4, which is equal to pi D squared. Okay, and then since we want pi, we want D, we're going to divide both sides by the pi. This cancels this, we're left with D squared here, and then this side we're left with 209,86 times 4 divided by pi. So if you want D, what do? You introduce the square root. So D is the square root of this. Let's calculate that. The square root of 9, okay, 209. Oh, the comments are getting in slow. I just got the comment now. 209,86 times 4 divided by pi. I'm getting 16,35. Are you also getting it? 16,35, the diameter. I'm getting 16,35 for the tensile. This is what I'm getting. So we need to calculate for the using tensile stress and also using the shear stress. So this is, now we're going to use the shear stress to find a suitable bolt. Use the shear stress to find a suitable bolt. The formula is still the same. Area is equal to pi D squared over 4. The formula remains the same. What's going to change is the area. Again, we did not get the same G. What did we get? Letter G. It was 177,8. Okay, 177,8, and then this is equal to pi d squared over 4. Remember, we're looking for d, so we're going to do what? Cross multiply. 177, 8 will multiply with 4. And then this multiplies with 1. Pi d squared. Divide both sides by pi because we're looking for d and not pi d. So this pi cancels this one. And then you remain with 177, 8 times 4 divided by pi, the square root if you want d. What is the answer? The square root of 170. I'm getting 15,045, so it's 15,05. 15,05. That is what I'm getting. Are you getting the same answer? Okay, so now we have answered our question. They said they wanted the diameter of the bolt, right? So we did the diameter of the bolt using tensile stress. We also did the diameter of the bolt using a shear stress. So now what you're going to do is to choose the one that is higher. You're going to choose the one that is higher. Using tensile, we got 16,35. Using shear force, we got 15,05. So now choose the highest. I gotta want the suitable bulk. So which one is the highest? It is this one where we use the tensile, right? It is the most suitable. Therefore, the most suitable bolt size is 16,35 millimeters. However, we are not done. Are you behind or you're okay? I can continue. If there's anyone that's behind, just comment I'm behind. If you're okay, just comment you can continue or I'm fine, so that I know. Okay, so I'm sure even if you're not using this textbook, this is the textbook that I'm using. Even if you're not using this textbook, I'm sure on your textbook this table is there. So you need to go to a table that is Schedule C. After getting your diameter of the bolt, you choose a higher one, then you go to Schedule C. We chose 16, right? We chose 16. So when we have chosen 16, okay, you need to know that in construction, be it's the number of trusses, it's the number of bricks, whatever it is, as long as you're doing construction, you can't go back. If you something according to maths, if we were to round off this, this would be 60, right? But in construction, we don't do this. You round off to the next number. Mathematically, it's 16, but in construction it's not 16. You can't go to a store and say you want a diameter 16 bolt. What about this 0.35? Okay, there'll be space there, so you round off to the next. Oh, you are behind. Okay, all right, let me just go back because someone says they're behind. Where do I start on number 1 straight? Here. Do I start here? Do I start here on number 1 where we use the tensile stress? It's fine. Let me just start there because I'm not sure if the comments are coming in slow or you are typing slow. I don't know. Okay, let me just start on number 1. It's fine. Okay, so number 1, remember they gave us the tensile stress and also the shear stress, so you need to get the diameter of the bolt using both stresses, and then at the end you're going to choose a higher one. So here we're going to use tensile stress to find a suitable bolt. We use a tensile stress to find a suitable bolt. The formula is area is equal to pi d squared over 4. Remember, we're looking for d, which is the diameter. The question said they wanted the diameter of the bolt, hence we're using this formula. So area is equal to pi d squared over 4. Our area, this area that we substituted, this one, it is the combined one. This one, it is the combined tensile stress. We got it. We calculated this. I'm not just assuming or anything. I got this. We all calculated this. It is the combined one, okay? So that is what you substitute there. And then is equal to pi d squared over 4. So since you want d, you're going to cross multiply this. I've made a cross here to show you that this is going to be multiplied with this. Hence here it's 209,86 times 4. And then which is equal to pi d squared. This pi d squared will be multiplied with 1. We can say that there is 1 here. So this multiplies with this, and then this multiplies with 1. Okay, so since you are looking for d and not d squared, you're going to introduce a square root there. When you introduce a square root, you'll get 16,35. After using a tensile stress to get your d, you are going to use a shear stress to get your d. The formula is still the same. This area that we substituted here, it is the combined shear that we calculated. And then you do the same, you cross multiply, then you're looking for d, so we are going to introduce what? A square root. We got our d to be 15,05, okay? And then we came here, and I said, we calculated d using the tensile. We also calculated d using the shear, right? So using the tensile we got 16,35, and using the shear we got 15,05. And I said you need to choose the highest. So when you choose the highest, it means it's 16,35, ne? And then you're going to write that therefore the most suitable bolt size is 16,35 because this is the highest one. And then I was saying in construction 16,35, you can't round it off to 16. You don't go backwards. This 3,35 matters in construction, okay? So what you're going to do is round off to the next whole number. Even if it was 16,01, you don't round off to 16. You're going to round off to the next number, which is going to be 17, not 16. It's wrong for you to round off to 16, regardless of what is after this comma. Again, you round up to the next one. So now we have 16,35. So 16,35 is going to be rounded off to the next number, which is 17. So now we go to this table, schedule C. We come to this table, schedule C, and then we have M16 there. Any number that is after the letter M is a diameter. Any number that comes after the letter M is a diameter. So our diameter here is what? Our diameter there is 17, not 16. Remember, it was 16,35 and we rounded it off to 17. So it's no longer 16. So there, we only have diameter 16. We don't have 17. Can you see? We also don't have 18. We also don't have 19. So the next diameter that we can use is 20. We could use 16. However, it would be wrong because it is 16,35. And in construction, these numbers after the comma matters again. So we can't use the 16 one. Our diameter, we rounded it off to 17, and there is no 17 on this table. You need to use a table called Schedule C. I'm sure you have it on your textbooks, even if you're not using this textbook. So it's Schedule C, and then on this table, this is where you're going to check what your next diameter will be. So as I said, we rounded off to 17 and we can't use 16. So it means the one that we can use is 20. Why 20? There's no 17, there's no 18, and there's no 19. Hope you understand that. So we're going to choose M20. So now when you conclude, you're going to say use the number. You're going to put number of bolts here. What are our number of bolts? You're going to use your number. Say use 8. Why 8? Why is it 8? Why is it 8? Remember, this is our eccentrical load. We have 4 bolts, 1, 2, 3, 4. However, they said it's 2 rows, so it's 4 multiplied by 2. So the total number of bolts is 8, not 4. Ne? So when you conclude, this is number 1. We're answering number 1. Use 8 M20 bolts. Where are we getting this 8? This 8 is the 4 bolts multiplied by the 2 rows that they said. And then this 20, it is the 17 that we rounded off. But in the table, in Schedule C, there is no 17, there's no 18, and there's also no 19. Hence we chose 20. We chose 20 because there was no 17, there was no 18, there was no 19. So use 8 M20 bolts. So that's all. We've answered number 1. Question number 1 said they wanted the diameter. Where is it? There is our question. Calculate the diameter of the bolt. So now we've calculated the diameter of the bolt. We've now calculated the diameter of the bolt. And then for number 2, unfortunately, my phone is on 3%. So this is goodbye. Sorry. We will not be able to do number 2, unfortunately, due to my phone being on 3%, and I don't have an extension. So that's a problem. So hope you enjoyed the lesson. You can contact me on WhatsApp at 064 026 2678. My WhatsApp number is 064 026 2678. 064 026 2678. That is my WhatsApp number. Enjoy your night. Thank you for joining me.